Here we establish relation between the zeros and the coefficients of a quadratic polynomial. Suppose we have a quadratic polynomial of the form ax square plus bx plus c. Now how many zeros are possible? See, the degree of a polynomial decides the number of zeros. Here the degree is 2, so number of zeros will be 2. See, the degree is 2, so number of zeros will be 2. Now, what are the zeros for any equation? Suppose there are two values alpha and beta which are the zeros of this polynomial. That means if I replace this alpha in this quadratic polynomial in place of x and solve it, I will get the answer 0. Similarly, if I replace this beta in this quadratic polynomial in place of x and solve it, I'll get another 0. That means there are two possible values at which this polynomial will become 0, and these values are called the zeros of the polynomial. Now how to obtain these zeros? There is a simple way of factorizing by splitting the middle term. Suppose I just factorize this polynomial by splitting the middle term. This you have done in your earlier classes. So I get two factors, x minus alpha and x minus beta. Then individually I put these factors equal to 0 and get the zeros for polynomial. This I am going to explain with the suitable example in the later half of the video. So we know that there are two zeros possible for a quadratic polynomial. Let we name them alpha and beta. Now what are the coefficients? Coefficient of x square is a. If you can just see, coefficient of x square is in a, and coefficient of x is a b. See, you can see here coefficient of x is a b, and the third thing is a constant without any x thing, and that is a c. Now what is the relation between these zeros and these three coefficients? The first relation is the sum of zeros. We write it like sum of zeros. So sum of zeros is alpha plus beta, because alpha and beta are the zeros. Then sum of zeros will be always equal to minus of b upon a, where b is the coefficient of x and a is the coefficient of x square. The second relation is the product of zeros. Now product of zeros will be alpha into beta, and that will always be equal to c upon a. So now we can see that we have a quadratic polynomial of the form ax square plus bx plus c. It has two zeros. Why? Because the degree is 2. So degree decides the number of zeros. So here degree is 2. So it is going to have two zeros. Now how to find these zeros? We just split the polynomial in two factors. Individually, we equate the factors with 0 and get the possible values of x. So by equating with zeros, the values of x will be alpha and beta. And these zeros, if we replace these zeros in the polynomial in place of x, the possible solution will be 0 always. Now, the coefficients are a, b and c, and the relations are sum of the zeros is minus b upon a and product of the zero is c upon a. Now to explain all these things with an example. Suppose I have a polynomial p of x and it is, say, x square plus 5x plus 6. Now I am going to split it x square. So 6 ones is a 6. Now the two factors of 6 such that their sum is a 5. So 3 2s is 6 and 3 plus 2 is 5. So this is the possible split. I am going to replace this 5x with 3x and a 2x and a 6 here. Now you can take x common, you get x plus 3, and a 2 common, again you get x plus 3. Now you can take x plus 3 common from both. From here you have an x and from here you have a 2. So these are the two possible factors. Now I am going to find the value of alpha and beta by equating individual factor with a 0. So x here is minus 3. So I have the first 0 alpha, that is a minus 3. To find another one, I'll equate this x plus 2 equals to 0 and x is equals to minus 2. So beta here is a minus 2. Now the relation. First one is sum of zeros. So left hand side will be alpha plus beta. Now what is alpha? Minus 3. And what is beta? Minus 2. So minus 3 plus minus 2 will get you a minus 5. Now what is your RHS here? RHS will be minus of b upon a. If you just look at the polynomial, what is a? A is the coefficient of x square, here it is 1. B is the coefficient of x, so here it is a 5. And c is the constant term, so here it is a 6. So I have made the list a, b and c. Now RHS minus b upon a. So b is a 5. So minus of 5 upon a is a 1. So upon 1. So on solving this I get another minus 5. So our LHS is equals to RHS. The second relation. Second relation is the product of zeros. So product of zeros is left hand side we have alpha into beta. Alpha into beta will be minus 3 into minus 2. If we multiply the 2 we get plus 6. Now what is the RHS? RHS is a C upon A. Now what is a C? C is 6 here in this case and A again is a 1. So 6 upon 1 is a 6 again. So we can see left hand side is equals to right hand side. Now a recap again for the entire question what I did. First of all I had the polynomial. I split the polynomial in two factors. I equated each factor individually with 0 to get the possible values of x. The value I get for x are the alpha and beta, which are the zeros for this polynomial. Now the sum of zeros and the product of zeros. So finally we established the relation between the coefficients and the zeros of the polynomial.